Observe this video of a human embryo at just 4 weeks of development. The most prominent features on its neck are these curved ridges stacked closely together. At this stage, they closely resemble the gills of a fish. In aquatic vertebrates, these ridges do form actual functioning gills. In humans, however, they are rapidly repurposed to construct the anatomy of the head, face, and throat. Biologists call this collective system the pharyngeal apparatus. Medical students often struggle to memorize adult cranial anatomy because the final layout of nerves, bones, and muscles appears chaotic. To understand the adult head and neck, you have to stop looking at the finished product and reverse engineer this modular embryonic template. Every jawbone, facial muscle, and laryngeal cartilage in the adult body is constrained by strict biological rules established during this brief 5-week embryonic window. This diagram shows a coronal cross-section of the embryonic throat. Outside, indentations form pharyngeal grooves. Inside, tissue pushes outward, forming pharyngeal pouches. Trapped between them are solid blocks, the pharyngeal arches. Where a pouch and groove meet is a thin pharyngeal membrane. Isolating a single arch reveals a standardized construction unit. Neural crest cells arrive to form bone and cartilage. Mesoderm provides material for muscles and blood vessels. Immediately, each arch is assigned its own cranial nerve and artery, permanently embedding into the muscle tissue. If you know which arch a muscle originates from, you automatically know its innervating cranial nerve, no matter how far it migrates. This split-screen diagram maps the template to the skull. Arch 1, the mandibular arch, is wired to the trigeminal nerve. Its cells form the middle ears malleus and incus, and the lower jaw. The mesoderm of Arch 1 forms the muscles that operate the jaw, the muscles of mastication, along with the mylohyoid, the anterior belly of the digastric, and the tensor muscles. Moving down, Arch 2 is the hyoid arch, receiving the facial nerve. Its skeletal derivatives include the stapes, the styloid process, and the upper body of the hyoid bone. Because Arch 2 carries the facial nerve, its mesoderm naturally forms the muscles of facial expression, alongside the stapedius, stylohyoid, and posterior digastric muscles. Arch 3 is wired to the glossopharyngeal nerve. It completes the hyoid bone, forming its lower part, and supplies exactly one muscle, the stylopharyngeus. The architecture follows strict sequential logic. Moving down arches 1, 2, and 3, their assigned cranial nerves move sequentially up, V, 7, and 9. Arch 5 is extremely small and disappears almost immediately in early development, leaving only arches 4 and 6. Arches 4 and 6 group together structurally. They share branches of a single massive nerve, the vagus nerve, cranial nerve X. Arch 4 forms the thyroid cartilage, the Adam's apple, and the cricothyroid muscle. These are supplied specifically by the superior laryngeal branch of the vagus nerve. Arch 6 drops lower, forming the arytenoid cartilages and all intrinsic laryngeal muscles. These receive the recurrent laryngeal branch of the vagus nerve. By dividing the vagus nerve across 2 specific embryological zones, the human body achieves the highly precise motor control required to separate phonation from swallowing. Leaving the outer arches, this animation takes us inside the primitive throat. Here, 4 pairs of pharyngeal pouches push outward into the surrounding tissue. Pouch 1 extends upward to form the middle ear cavity and the eustachian tube. Because these originate from the throat lining, throat infections can easily travel up this path to become ear infections. Pouch 2 forms the palatine tonsils at the back of the mouth. Pouches 3 and 4 present a distinct spatial paradox during their migration. Pouch 3 forms the thymus and inferior parathyroid glands. Pouch 4 forms the superior parathyroids. Tissue from pouch 3 physically migrates further down the neck, completely overtaking the tissue from pouch 4, resulting in an inverted final position. This mechanical overtaking yields a strict memory role for students. 3 goes lower, 4 stays higher. Returning to the exterior profile of the embryo, we must evaluate the fate of the 4 pharyngeal grooves. Only groove 1 maintains a permanent anatomical fate. It deepens to form the external auditory meatus, the ear canal. Where groove 1 meets pouch 1, pharyngeal membrane 1 aligns perfectly to create the eardrum, or tympanic membrane. The remaining exterior features are erased by a massive mechanical event. Arch 2 undergoes a rapid downward overgrowth. As Arch 2 sweeps downward, it completely buries grooves 2, 3, and 4 beneath a thick layer of tissue. These buried grooves are cut off from the surface, coalescing into a temporary, enclosed, fluid-filled space known as the cervical sinus. The smooth profile of the normal human neck relies entirely on this temporary cervical sinus dissolving and disappearing completely as development continues. When congenital anomalies appear in the face and neck, they are highly predictable mechanical failures within this exact blueprint. If the cervical sinus fails to dissolve completely, the fluid-filled void remains. In this clinical video, the result is visible as a branchial cyst, a smooth mass protruding from the lateral aspect of the neck. In this diagram of DiGeorge syndrome, caused by a microdeletion on chromosome 22, we see the specific failure of pouches 3 and 4 to develop and migrate. Without pouch 3, the patient lacks a thymus, resulting in severe immune deficiency. Without pouches 3 and 4, there are no parathyroid glands, leading to dangerously low calcium levels. The thyroid gland begins at the tongue and descends into the neck. If it leaves remnant tissue along its migration path, it creates a thyroglossal duct cyst. Because the residual tract remains tightly anchored to the tongue above, the cyst moves upward whenever the patient swallows. And if Arch 1 and Arch 2 suffer a developmental delay, the delicate sequence of the malleus, incus, and stapes is broken, resulting in congenital conductive deafness. The adult head and neck only appear chaotic if you look at the final outcome. By mastering the strict rules of the pharyngeal apparatus, the anatomy ceases to be a memorization challenge, revealing itself as a logical sequence of structural engineering.